All right, welcome to 5-2, day 2. So let's go ahead in our note 2, where it's at 5-1, day 2, graphing and in behavior. So in behavior is basically the way that the arrows point on a graph or on a function. So if you look at this, kind of like this one's on the left is going down, the one on the right is going up, and that's kind of what in behavior is. So we use these symbols for positive infinity and negative infinity. So let's go ahead and look at this first little problem here. So just kind of look at this graph, and that's why I made the notes for you so that you could just kind of watch what I'm doing here. So the first thing we're going to do is bring up a pointer. Let's see if I can do that. There we go. Okay, so if we look at when f of x approaches negative infinity, so that's the y part, and the x is the x-axis. So as x approaches negative infinity, so as x goes to the left, what is y doing? Y is going down, so it's approaching negative infinity. As x approaches positive infinity, what is y doing? Y is approaching positive infinity. It's going up, right? And so this is called an odd function. So like x to the third, x to the fifth, x to the seventh, those are all odd functions. So whenever it has a degree that's odd, it makes this shape, and we talk about these two behaviors. Now when the degree is odd, but the leading coefficient is negative, for example, it could be like y equals negative x to the third power. That would be an example of having a degree that's odd and a leading coefficient that's negative. So you can see that it's basically reversed. It's kind of like flipped across the y-axis. So as x approaches negative infinity, so as it goes to the left, what is the graph doing? It's approaching positive infinity. It's going up. As x gets bigger, as x approaches positive infinity, y approaches negative infinity. Right? So all odd functions that have a positive coefficient make this sort of shape. All odd functions that have a negative coefficient make this sort of shape. So if we look at even, so we have an even function, which means that it's like y equals x to the fourth, or x to the fifth, or something like that. Or sorry, x to the sixth, or x to the eighth. So we're looking at when x approaches negative infinity. So as the graph goes to the left, y is approaching positive infinity. As the graph goes to the right, y is also approaching positive infinity. So whenever the degree is even, the in behavior goes in the same direction both times. Whenever the degree is odd, it goes in opposite directions. So now let's look at when the leading coefficient is negative. So this could be an example of y equals negative x to the fourth. So we can see that as x approaches negative infinity, as the graph goes to the left, y is getting smaller and smaller, approaching negative infinity. As x gets greater and greater, as it approaches positive infinity, the graph is going down, approaching negative infinity. Again, because it's even, both in behaviors go the same direction. So describe the degree. So on this one, we're looking to see if it's odd or even. Well, because it's got opposite directions, that means that the degree is odd. And the leading coefficient. So we go up here and kind of match. Oops. We go up here and we look to see that it looks like this one, where it's going up on the left and down on the right. So that tells us that the leading coefficient is negative. And that's it. That's all I have to do? Yep. All right, so now let's describe in behavior. Describe the in behavior of the graph of the polynomial function by completing these statements. F of x approaches blank as x approaches negative infinity. So let's look at this. This is even. Even and positive. So let's go up and look at even and positive. Even and positive looks like this. So y is going up in both cases. So we go down here and we're going to write positive infinity and positive infinity, right? Because all it matters is that this is even and this is positive. And then it always looks like some sort of thing like this. So this next one, we look at this guy. That's odd. Odd tells us that it's going to make one of these two shapes. And then we look at this guy to see that this is positive, so it's going to look like this first one. So as x approaches negative infinity, the y is going down. As x approaches positive infinity, the y is going up, the graph is going up. All right? So now let's look at graphing. Graphing is actually not too bad. You'd think it would be awful looking at that function, but it's really not too bad at all. All you do is make a t-chart, and we just pick these same 6 numbers, or same 7 numbers. So -3, -2, -1, 0, 1, and 2, and 3. And that's it. And we just plug those numbers into the equation, just like we did with our direct substitution. You just plug these guys in all 3 places, and we do this over and over and over. So a great place to use your calculator. So in my calculator, I'm going to put negative, parentheses, -3 cubed, plus 2 parentheses, -3 squared, plus 2 times -3 minus 1. So we get the awful number of 38. A little bit big on our graph there. And then we plug in -2. So you do exactly the same thing that we did, except for every place you have a -3, you plug -2 in, and so on and so forth. So go ahead and let's fill in the graph. Get 11, 0, -1, 2, 3, and -4. So we'll go ahead and plot those points. I'm not going to plot the -3, 38, or the -2, 11. So I'm going to plot -1, 0. So I'm going to go to the left -1 and up 0. I'm going to go over 0, down -1. I'm going to go right 1, up 2. I'm going to go right 2, up 3. And I'm going to go right 3, down 4. So you can see that our graph is kind of doing something like this, and it's going up, and it's coming back down, which makes sense because we have an odd function, and it's negative, which means that it looks something like this. All right, so we did a good job. So the degree is 3. The leading coefficient is -1. So as x approaches negative infinity, y is getting bigger and bigger. As x approaches positive infinity, y is getting smaller and smaller. All right, we do the same thing on number 1. So when we put this in our calculator, we'll have parentheses -3 to the 4th power minus 5 times -3 to the 2nd power plus 6, so on and so forth for each of the numbers. So for the first one, I get 42. Second one, I get 2. For -1, I also get 2. For 0, I get 6. For 1, I get 2. For 2, I get 2 again. And then we look at 3. And for 3, I get 42. So we graph these points. I'm not going to graph these crazy ones. So I'm going to go left -2, up 2. I'm going to go left -1, up 2. I'm going to go left 0, or nowhere 0, and up 6. 1, 2, 3, 4, 5, 6. I'm going to go right 1, up 2. Oops. I'm going to go right 2, up 2. And I'm going to go right 3, up 42. So we know it's going to go up. So it's going to do something like this. Kind of looks like a little W thing going on, where it goes up to where those two 42s are. So basically, the end behavior, if we look at this, is positive in both directions, which is the way that we anticipate it being, since the degree is even, and the leading coefficient is positive. So tomorrow in class, we'll do those problems. If you're not going to be there, that kind of gives you an idea of what you need to do. Otherwise, we'll work through those together in class, so no sweat.